Day 1, Session 2 of our 2-day professional development series. My name is Brooke and I am thrilled to guide you through these upcoming sessions. A few reminders: the importance of registration. Please ensure you are registered for each session you wish to attend. Registration ensures we can supply the necessary materials, updates and follow-ups for each session, and ensuring a beneficial experience for all. Each session will run for 1 hour, and this will include our main presentation with a 15 to 20-minute question time, allowing you to delve deeper into the topics and engage directly with our experts. Concluding, as part of each session, there will be a formal assessment, which is an essential part of our professional development series and your points. Interaction and steps for success. We encourage interaction and engagement throughout the day and appreciate your efforts for joining us from different time zones. If you join me for multiple sessions today, you may hear me repeat myself several times. However, our recommended sessions will start on time with access closing 5 minutes after commencement. Your CPD certificates will be issued by the presenters to be received no later than next Friday, the 3rd of November. Recordings of the sessions will be made available for everyone to watch again following our 2-day wrap-up, and we encourage you to ask questions via the Q&A function, which you will find at the bottom of your screen in the black control ribbon. Each session has technical specialists on hand to answer your questions live. As part of the formal assessment and guidelines, each presentation includes a questionnaire which you must complete and is to be kept for your own records. Questionnaires have been previously emailed. However, they can also be found via the resources section at the bottom of your screen. Please note, if you are after a CPD certificate and have joined as a team or on someone else's invite link, please make the ARC agency team aware so we can distribute your certificates. We do distribute per individual login and your RSVP details. For any clarifications and to ensure your certification, please email me, Brooke, at thearcagency.com.au. I'd like to thank all of our presenters for sharing their expertise, and our attendees, thank you for your commitment to professional development. Let's get on with our learning journey. As our structures reach ever greater heights, safety becomes even more critical. We shift our focus now to the intricate world of facades, where aesthetics and safety must go hand in hand. With the dynamic shifts in architectural trends, and ensuring the resilience and beauty of our buildings is paramount. Network Architectural is here to lead us through safe facades, future-proofing your specifications. Let's dive into this session and uncover the facade's pivotal role in contemporary architecture. Thanks.
Thank you very much, Brooke, and good morning, everyone. My name is Llewellyn Regler. I'm the National Technical Manager for Facades at Network Architectural. I have been in the industry for 6.5 years, getting in just before Grenfell, and I'm still here. So with that, we are going to go through the Safe Facade Future-Proofing Your Specifications CPD presentation. So the contents today, we're going to be going through our state of the facade market, looking beyond compliance, designing for extreme weather, and future-proofing your specification. And with that, we'll go through the learning outcomes, which are understand the state of the facade market today and how the industry has evolved since the Grenfell disaster, explain how looking beyond compliance can help us design safer buildings by exploring Australian and international testing methods and standards, design for extreme weather and understand the importance of impact and pressure testing for extreme weather conditions such as hail and severe wind, and outline key considerations and inclusions when specifying safe and future-proof facades. So to start off, we're going to go through the state of the facade market and how the industry has evolved since the Grenfell disaster. So Grenfell Tower, the catalyst for change. So everyone here, I'm assuming, is very familiar with Grenfell. Like I said at the beginning, I joined just before Grenfell. So Grenfell Tower, a perfect storm. So Grenfell was an overclad of a council housing building in the Kensington-Chelsea government area, and the materials that they used for it were 100% PE core panels with combustible polyisocyanated PIR foam insulation. So this system was a ventilated system. It was a vertical channel subframe. So what this meant was that it had a cavity behind the panels, which allowed that fire to spread really rapidly. It didn't have any cavity fire stop barriers. The cavity barriers, they actually did have some on that building, but they were installed incorrectly and upside down, which they didn't activate. Regardless, though, having a cavity barrier in the cavity is an excellent idea if the fire on the outside of the building isn't going to keep leapfrogging it, which of course happened with Grenfell anyway. You then had the tilt and turn open windows with the inward opening casement windows. So again, because we have this chimney effect with the subframe, we have open windows, which as compared to the multiple polyethylene fires in Asia, in the Middle East, they had sealed windows in air-conditioned buildings, so they didn't have the fire didn't have any egress points to get inside the building. Because of all of this, it just was the perfect storm. So all of these products contributed to it. The building code, which allowed it to happen, the suppliers themselves. So Grenfell Tower really was a perfect storm. There was nothing that went right for this building. Even the fire evacuation process was very restricted. You either had to stay in your apartment. The people that did get out actually got cyanide poisoning, and then on top of that, they were competing with firefighters on the one stairwell anyway to get into the building. As I said before, it was a perfect storm. The British government have actually taken 50% responsibility for Grenfell, which I think is really good, with the other 50% of that being put onto the suppliers. So with Grenfell came the reinvention of solid aluminium. So as a result of Grenfell, the market turned back to solid metal products such as aluminium and steel rather than using composites. So composite became a tarnished word in the facade industry, with most architects and building consultants refusing to specify or sign off on composite material. Shortly after that, around 2019, insurance followed, with many having a no composite clause in their personal indemnity insurance. So solid aluminium and the shortfalls reappear. So since the prolific use of solid metals, particularly 3mm solid aluminium after Grenfell, many have turned back to composites for the same reason they did 30 years ago. The aesthetics of solid aluminium in both color consistency and oil canning are simply not up to today's modern standard. With that, composite facade panels have now come back into play, providing they satisfy the deemed to satisfy requirements of the National Construction Code. So here's an example of oil canning. So that panel on the left, so these are 3mm solid aluminium panels that were installed up in the Brisbane CPD. Oil canning happens as a natural phenomenon with these panels. They will expand and contract over time, and because of that, they'll get that pillowing effect in the facade. On the right is a 4mm aluminium composite panel, which is demonstrating superior flatness and rigidity. Here is the slide on the inconsistent color. So this is the inconsistencies in between panels with 3mm solid aluminium. So on the left, you can see that the panels have been put up, and they've been put up in the correct way with the arrows all pointing the same way. They've taken the film off of these panels, and they've noticed that some of these panels have that color inconsistency in between them. Now, that was not a aesthetic that the architect was going for. These are the inconsistencies with the panels themselves. The manufacturer actually came back and said that those panels were well within the color tolerances with a delta E value of 2, so it was within that. So therefore, there was no warranty recourse, and these panels weren't defective. Of course, that would not be the case with any other panel, but they were for this particular one. Aluminium composite materials are coming back. Hooray. So insurance companies are now willing to provide cover on composites or bonded laminates, provided they comply with the National Construction Code. So government programs such as Project Remediate and Cladding Safety Victoria have now also come on board after doing their own testing, and are putting these products forward as a less riskier option than solid metal products. So facade supply companies have in this way had to adapt to a radically changing market, and not just become a supplier, but a partner in recladding and new builds. So now we're going to go into a bit more detail about the testing. So looking beyond compliance. So using global and local fire testing methods to help us design safer buildings. So moving forward with BCA and compliance to 1530 Part 1 and non-combustible. So compliance for facades can be met with either one of two ways. The deemed to satisfy pathway under NCC 2022, which is C2D10, whereby the NCC lists materials that are deemed to satisfy non-combustibility or pathways in which they can achieve that. The second is a performance solution pathway under CB3. This method requires a large-scale AS5113 test, where the product must be installed and tested as it would be on site and achieve an EW or an external wall classification and be assessed and signed off by a fire engineer. It must be then installed on site as it was tested. This pathway is difficult to pass and get an assessment for and is traditionally not used. So pathways to compliance, and this is the CB3 verification method. Now CB3 is the only way forward for combustible cladding on type A and B construction. So as an example, if you wanted to use a product such as ALPOLIC FR on a type A or B construction, they would have to be using that CB3 verification method. But as I said before, this is rarely used, if ever. So moving forward, building code, instead of using the performance solution pathway, we use the other pathway, which is either a deemed to satisfy solution under the NCC or it is non-combustible. Now, DTS is the best, cleanest way to comply. And there are two tests for DTS compliance if you're using an aluminium facade panel. One is AS1530 Part 1 and the other is AS1530 Part 3. So AS1530 Part 1 is the non-combustibility test. So products made into sample sizes 50 mil wide by 50 mil high and are loaded into a 750-degree chamber. This test has two failure criteria, and if the product has a sustained flame for longer than 5 seconds or has a temperature rise of 50 degrees or more, then it is a failure. There is a concession given for this test for multi-layered assemblies that all layers have to be tested and pass AS1530 Part 1, and all up this test goes for an hour. The compliance of a material to the building code non-combustibility definition is determined by conducting an AS1530 Part 1 standard combustibility test. If the material satisfies the criteria outlined in the test method, the material is not deemed combustible. So this slide goes through what we've just covered off. However, down the bottom, accordingly, this clause does not eliminate the assessment of any multi-layered assemblies, but states that each layer should be tested separately to AS1530 Part 1. AS1530 Part 3 component test and the introduction of Schedule 6. AS1530 Part 3 is for material for fire hazard properties is the second test, which involves a sample being progressively moved closer to a radiant heat panel. The test goes for 20 minutes, and over that period, it tests for ignitability, flame spread, heat release, and smoke release. One flaw with this test originally was that it was used to demonstrate compliance for polyethylene composite panels. Because there were no penetrations through this, it only tested the aluminium, which gave it great results. This has been changed with Schedule 6 of this test, which mandates that penetrations must be done with this test so it can give an accurate representation of all layers. And as note down the bottom, this is the pathway for CPSP reproval on Project Remediate. You have to do a AS1530 Part 3 with Schedule 6 and test it with different penetrations and caulking through it. So NCC in compliance with 1530 Part 1 in Type A and B construction. So this is C2D10, which lists materials when entirely composed of itself are non-combustible, may be used wherever non-combustible material is required. So this section here of number 5 is a new addition to the NCC, which lists a bunch of materials, one of them being concrete. So previously concrete, I believe, didn't have a clear pathway. My favorite one though is terracotta. So terracotta, as an example, is baked in a 1200 degrees Celsius kiln, though it didn't get a concession under the building code previously, now it does. And then down the bottom, it has the following materials may be used wherever non-combustible material is required. So it lists plasterboard, fiber cement sheeting, pre-finished metal sheeting having a combustible surface finish, sarking materials, and bonded laminate materials where the laminate, including the core, is non-combustible. The adhesive layer does not exceed 1 mil in thickness, and the total thickness of the adhesive layer does not exceed 2 mil. The spread of flame index and the smoke developed index of the bonded laminate material as a whole do not exceed 0 and 3 respectively. And point number D, when located externally, are fixed in accordance with C2D15. Now, C2D15 was an addition to this part of the bonded laminate clause, which states that the product must be fixed through all layers of the lamina, and gives an example of cassette fixing, which is fine. Cassette fixing is the preferred method, which we recommend when installing our products. So this slide here, compliant to the building code. Does that make it fit for purpose? So solid aluminium melts at 660 degrees. So fires, especially the AS5113 test, reach this temperature very quickly, resulting in large amounts of liquid aluminium falling from a building. The second point is corrugated panels by design behave with an internal chimney effect within the panel, creating a rapid spread of flame beyond the fire source. So again, these are products that meet the deemed to satisfy criteria. However, when you put them into a large scale test, they perform differently to what they would in a component only test. So this is just an extra little bit to see whether or not you should ask a question of getting more fire test results. So DTS mandatory, compliant to 1530 Part 1 and Part 3, and optional is test with 5113. So 5113 isn't mandatory for deemed to satisfy products, but it is optional. So 5113 is a large-scale fire propagation test. So rather than component-only tests like 1530 Part 1 and Part 3, which we've just been through, this test holistically tests the facade panel as well as the system behind it in order to get a better understanding of how the products interact in a fire. So AS 5113 is the Australian adoption of British Standard 8414 Parts 1 and 2, with 5113 having the notable inclusion of the debris clause. At the core of this test is whether the products will propagate the spread of fire separate to the ignition point. For example, the facade panel might not spread fire, but can open the cavity, exposing the insulation which could then itself catch fire and spread internally up the cavity. By using this test method, we can see what products work well with each other and what products don't. This test also incorporates a wing wall as opposed to other tests, which we'll go over now. I will like to point out again, just down that bottom, 5113 is not compulsory in order for material or system to be used in a facade, meaning that if you have deemed to satisfy compliance, that is the way forward for your product. 5113 is always good to do as an extra though. So here are two side-by-side slides. So this is 3mm solid aluminum and ALPOLIC NC being tested at CSIRO. So that was the beginning of the test, and on the right is the end of that test at that 30-minute mark. So you can see there that the aluminium has actually fallen off that top of the panel itself, and that has melted significantly. While the ALPOLIC NC on the right, you can see there that it hasn't reached the top yet, and the panels at the top are still fixed on. So this is a test result comparison between ALPOLIC NC and 3mm solid aluminium. So ALPOLIC NC on the right passing 8 of the 9 criteria there, with the failing the debris criteria down the bottom, which is 2 kilos or less. The ALPOLIC NC had 6.65 kilos of debris, with the largest piece of that being 180 grams. 3mm solid aluminium failed 7 of the 9 criteria with 43.5 kilos of debris, largest piece of that being 23 kilos. And this is a comparison of the debris. So we were able to fit ours into a little plastic bucket there that you can see. Again, total 6.65 kilos, and that 3mm solid aluminium there. So the largest single piece of that debris was 23 kilos. So now we're going to look at global large-scale tests. So NFPA 285, this is a North American test specifically called the Standard Fire Test Method for evaluation of fire propagation characteristics of exterior wall assemblies containing combustible components. So this is an 8-meter tall wall with no wing wall and a gas burner rather than a timber crib, which simulates a fire coming out of the building and onto the facade and seeing how much the fire propagates up the facade. The other one is 13501-1. So fire classification of construction products and building elements. So this is one of the most stringent fire test standards in the world and incorporates 5 different tests to get a classification ranging from A1 to F. A1 being the highest and best rating. Because of this stringent nature of this test, it is widely accepted globally. So again, instead of a component-only test, we're actually going to look at a large-scale test. This was performed in the early 2000s. So on the left is a 100% PE core aluminium composite panel, and on the right is our ALPOLIC FR. So on the left, you can see there that the polyethylene panels are actively starting to contribute towards that fire, giving off that toxic black smoke. On the right there, you can see with the ALPOLIC FR, nothing's starting to happen yet. This is 13 minutes in, and the facade panels on the left are well and truly alight and contributing to fire. ALPOLIC FR on the right, you can see that the panels are being damaged, but they aren't actively contributing to the spread of fire. Now this is 3 minutes later, so you can see here that the facade is well and truly alight and is starting to drop some of that flaming debris down. Now this is how polyethylene fires can spread so quickly around a building. They will go up the building and then they will drop that flaming debris down. And you can see more of that context here, where that pile has grown exponentially larger than that 1.5 minutes. So that's how they actually move so quickly around that building. They will drop down, they'll ignite the bottom of the building, and they keep going up. ALPOLIC FR on the right, again, nothing's happening to it. The fire is damaging the panels, but they aren't igniting and contributing like the polyethylene panels are on the left. And that's the test stopped. Now, one of the interesting things here is that it gave off a really big fire. However, you can see there that actually not all of the facade was actually alight. In fact, quite a lot of it still remains, which suggests how much heat that actually gives off. And the equivalent is about 5 litres of petrol per square metre for the polyethylene panels. So designing for extreme weather conditions. So how will the product perform under extreme UV, hail, and wind? So extreme sun/UV violet rays, and what type of coating performs the best. So here we can see that the quality of the paint coating is key to protecting against UV rays, and the fluoropolymer coatings have the best weatherability, so PVDF and FEVE. So with the testing methods, the sunshine weather meter test and natural exposure test, the Lumiflon FEVE coating stands out there in the red at the top, retaining its gloss over time. However, you can see the PVDF has dropped off after a certain amount of time. One of the most important questions here is, does your product warranty include fading? So extreme sun UV rays, why Lumiflon FEV performs better than the PVDF? Well, as you can see there at the top, you've got the FEV Lumiflon and PVDF down the bottom. So the chemical bond between the carbon atoms and the fluorine atoms is too strong to be broken down by the sunlight. So this means that the polymer is not degraded by UV radiation from the sunlight. The alternating structure of the Lumiflon resin also increases the strength of other chemical bonds in the polymer, which protects the entire coating against degradation. So the PVDF and standard FEV breaks down as the bond energy is less than the UV rays. So you can see that the FEV Lumiflon has a bond energy of 414 to 424, whereas the PVDF down the bottom is 379, while the UV rays of 411 kilojoules per molecule are constant over all three. Now the UV rays at 411 kilojoules per molecule, that's as strong as that it can be. So you can see the bond energy of the FEV is 414 to 424. It's stronger than it, so it's not going to break down. With the PVDF, over time, it will begin to fade and break down that color. Hailstorms and impact performance. So hailstorms are becoming more frequent in Australia, especially around Sydney, Brisbane, and Canberra. So hail testing measures the impact of freezer ice balls on the facade panel to see how much of an indentation the ice leaves. So this is important not only for the durability of the panel, but also for the aesthetics of the panel. No one wants to have a facade that can be easily dented, as you can see there in the photo. So testing was conducted in accordance with the test procedures of the Texas Tech University Variation for Wall Materials for impact resistance testing of rigid roofing materials by impacting with freezer ice balls. So testing was required on an observe and report basis with measurement of indentation due to the impacts. So the client, it was us, requirement was that the sample panel was to be impacted at a nominal speed of 32.1 meters per second with ice balls of 3 different sizes, and then to measure the indentation for each product. So the results that you can see here, so the hail testing measures the impact of freezer ice balls on the facade panel to see how much of an indentation the ice leaves. It's important not only for the durability of the panel, but also the aesthetics. Obviously, you're paying a lot for a facade. No one wants to have a facade that can be easily dented. So if you look at the graph here, so you have the corrugated core product that performs very poorly. 3mm solid aluminium performs reasonably well, but the ALPOLIC and C perform the best. So again, just going beyond the basics of the specification and seeing how you can look at a product and future-proofing it as much as you possibly can. So this is a little bit different. This is a high wind performance or cyclone testing. So cyclone testing is a more extreme pressure test. This test is primarily designed for the northern parts of Australia, though facade engineers can reference this test for other high wind load areas. So this test repeatedly puts the facade under a nominated pressure to simulate the effects of a cyclone and to see how long the product, in this case the facade, can withstand those pressures. Apart from cyclone areas, it's a good test to see how the stiffeners, structural silicon for the stiffeners, and the spacings of those stiffeners work with the panel in order to make it as durable as possible. By having the above tests and using them in conjunction with each other, then the consultant can have the best possible knowledge that the product will not only be fit for today's purposes, but for the future as well. And as you can see there, our particular product has 5.5 kPa wind load pressure, which is amazing. So future-proofing your specifications. By utilizing what we've been through in the previous slides, such as fire testing data and weatherproofing, you should make an informed decision based on what the requirements of your project are for both today and in the future. So these are all questions to ask when designing a building and specifying product. So know the product inside and out, long-term durability. So what is the expected life cycle of the panel? Is the warranty from a manufacturer or a local supplier? Does the warranty require maintenance clauses in order to maintain that warranty? And what is included in the warranty, and does it include labor and access? Will UV break down the facade coating over time, and can it be recycled at its end of life? And a good expectancy for a facade panel is 50 years, and there are a number of panel recyclers who can confirm if the product can be recycled and reused at a later date. So the product life cycle costs. What is the life expectancy of the panels? As we said before, 50 years is a good indication. How long is the warranty? Does the product require any ongoing maintenance to maintain that warranty? And panels that use a PVDF coating normally require cleaning every 6 months, and panels that use an FEVE coating normally do not require any cleaning or ongoing maintenance. So the average cleaning cost is $14 per square meter, and if the facade requires cleaning every 6 months, there's an additional $28 per square meter annually for the lifetime of the facade. This is key for owners, and which is important to be written to the specification, especially for Class 2 buildings in New South Wales under the DBP Act. You have to make sure that when you're handing over the building, that's all included in the warranty documentation that you hand over. So important to remember. So then the product inside and out, cavity barriers. So cavity barriers are currently required if you have a timber frame multi-residential building or if you are doing any work under Project Remediate. However, cavity barriers should be considered as best practice when designing any building, as they help to seal off and protect the cavity and prevent fire spread going up the cavity. As always though, when it comes to facade products, ensure that it has some large-scale testing on top of any other requirements it will need. Know the product inside out, sustainability. So does the product have an environmental product declaration, or EPD? EPDs are cradle-to-grave product assessments that detail the amount of embodied carbon that a product has over its life cycle. They contribute to Green Star points for a building and are a must in terms of green building and sustainability. Many products state that they can be 100% recycled, but don't detail the energy requirements used to make the product or to recycle it. In terms of sustainable construction, a product with an EPD is the only way to go. And again, just because you say your product is 100% recycled, but you can't actually prove it with any documentation to do that, it doesn't contribute towards Green Star points. Does the product use recycled aluminium in manufacturing? And there are a number of suppliers who use the aluminium from Aluminium Stewardship Initiative suppliers. Is the manufacturer credible, and do they have all their sustainability accreditations in place? So this is an example of a specification. Here someone has nominated ALPOLIC NC. You can see that they've actually been extremely specific about it. So they've specifically nominated different parts of our product, which are unique to our product, in order to help guarantee and safeguard that specification. So ALPOLIC NC, the safest. So ALPOLIC NC meets the deemed to satisfy requirements of NCC 2022. It is approved for Project Remediate. It does meet the Euroclass A1 classification, which again is considered the strictest fire protection standard for building materials in the world. It has been tested to AS5113 large-scale fire test and outperforms solid aluminium and corrugated panels. And it does come with a full replacement manufacturer's warranty from Mitsubishi, which means that if it's a defect in the panel and it was Mitsubishi's fault, such as delamination, color change, etc., they will pay for a contractor and labor to go and replace that panel. ALPOLIC NC, superior aesthetics. So superior aesthetics for lifetime of the facade, guaranteed color consistency, no oil canning, superior flatness and rigidity, comes standard with a Lumiflon FEVE coating, does not break down with UV, and retains its gloss and depth for 50 years. Most sustainable, so it does come with an environmental product declaration, which was produced by Good Environmental Choice Australia. It does use recycled aluminium from 2 different suppliers who are both part of the Aluminium Stewardship Initiative. It comes with a 50-year plus life expectancy and has no cleaning or ongoing maintenance required. Lowest life cycle cost, so no ongoing maintenance required. You can save on average $28 per year annually for the lifetime of the facade if you are comparing with other 3mm or corrugated core PVDF coated products. It comes with a 50-year life expectancy and does come with a full replacement warranty, including material, labor, and the access. So it has a huge benefit to owners if they're commercial or residential otherwise. So these are a couple of the projects where we have used ALPOLIC FR. Now, ALPOLIC FR is still sold in Australia. We primarily market it at Type C construction or internal use. However, we try very hard to keep it on buildings when it's safe to do so. So Barangaroo Precinct in Sydney was one of them, has 60,000 square meters of ALPOLIC FR in it. 180 Ann Street is a great example of how flat the panel is because you can see the reflection of the neighbouring building. Here is the Queensland Children's Hospital. So this is 55,000 square meters, and Royal Adelaide Hospital, which was a mixture of ALPOLIC FR and ALPOLIC A2. Both of these buildings have been assessed with the product staying on. So ALPOLIC FR is also in Q1 Tower and Surface Paradise. So this is great for us. It has was installed 400 meters away from the breaking surf, hasn't had any color degradation or any weathering to it, and still looks the exact same as it did 20 years ago. And Marina Bay Sands in Singapore, which is a great flagship project for us as well. So thank you very much for paying attention and going through the CPD with me. We'll now go through the CPD questions. So question number 1, with the resurgence of solid aluminium, what shortfalls have reappeared? A, oil canning. B, inconsistent color. C, melts at 660 degrees. D, it's a heat conductor. Or E, all of the above. The answer is E, all of the above. Question 2, AS5113 large-scale fire testing is the best indicator for A, product's performance in a fire, B, the facade system's performance in a fire, C, flame propagation, or D, all of the above. The answer is D, all of the above. Question 3, what are the benefits of using a product with a Lumiflon FEVE coating? Question A, no ongoing maintenance. B, more sustainable. C, does not break down with UV. D, superior aesthetics for lifetime of the facade. E, lower life cycle costs. Or F, all of the above. Well, if you guess all of the above, you are correct. Question 4, with the increase in extreme weather, name 3 tests that show a product is fit for purpose. A, 5113. B, impact hail testing. C, cyclone testing. Or D, all of the above. You guessed it, it is D, all of the above. Question 5, which global standard is considered the benchmark in fire testing? A, EN 13501-1, B, AS 1530 Part 1, C, NFPA 285, or D, AS 1530 Part 3. The answer is A, EN 13501-1. Question 6, what questions should you ask the supplier about the product warranty? A, does the warranty include full replacement, including materials, labor, and access? B, is the warranty backed by a credible manufacturer? C, is there any ongoing maintenance required to maintain the warranty? Or D, all of the above? The answer is, of course, D, all of the above. Question 7, what is the average yearly cost per square meter to clean a facade twice a year? A, $28 a square meter, B, $10, C, $14, or D, $40? The answer is A, $28 per square meter. And question 8, does compliant mean the product is fit for purpose? A, yes, always. Or B, no, it's important to consider other factors, as an example, extreme weather, location, product life cycle costs, sustainability. The answer is B. It is important to consider all of those. Thank you so much for your attention. I sincerely hope that you enjoyed it and got something out of it. Go back to Brooke now, and we'll go into the next part of our Q&A. Thank you so much, Brooke, and thank you very much, everyone, for your time.
Good morning, everyone, and welcome back, or welcome to our second session of the morning. We're going to have Llewellyn joining us back, also with Anna and Clint from the Network Architectural team, an eye-opening session on the importance of safe facades and future-proofing our designs. So, and a bit of an update from last session, bringing in 2022 details as well. A reminder to everyone, please make sure your questions are coming through. I want to make sure I'm asking hard ones, guys. At the bottom of your screen, the Q&A, please send through any questions you may have. Hopefully, Llewellyn didn't stump anyone with the formal questions. I will run through those really quickly to make sure you've got those covered off. With the resurgence of solid aluminium, what shortfalls have appeared? You would be right if you said all of the above. AS5113, large-scale fire testing is the best indicator for, you've guessed it, all of the above. What are the benefits of using a product with a Lumiflon FEVE coating? Again, Llewellyn, you need to make these harder next time. All of the above. With the increase in extreme weather for number 4, name 3 tests that show a product is fit for purpose. I'm not even going to tell you the answer to that one. Number 5, which global standard is considered the benchmark? So this is not an Australian standard. This is a global standard, EN 13501-1. What questions should you ask? A lot of them. I think that's the point. Ask the question so you're getting the right information. And again, it's all of the above. What is the average yearly cost per square meter to clean a facade twice per year? And remembering, we don't have to do this with the NC. It's $28 per square meter. And our last one, does compliant mean the product is fit for purpose? No. Again, ask your questions. It's important to consider all of the factors: extreme weather, location, product life cycle, sustainability. Hopefully that has answered all of your questions. A few easy ones in there, but a few others coming through. Let's jump into some harder questions. I will ask you harder ones now. We've got Llewellyn, we have Anna, we have Clint here with us for 20 minutes or so. Perfect time to get those burning questions out there. See what I did there? Are you curious about a specific design principle, or you want to know more about ALPOLIC safety, compliance, best practice? Your chance is now. I will throw one out to you. Large scale testing is being referenced. Should we always do both? Component, large scale, always? What do you think?
In my opinion, yeah. The component only testing really only gives you a small indication of how a product's going to perform. It's kind of done so that it can give you a better understanding of how it will perform in an actual fire when, we actually have tests that will see how a product will perform in fire, and it's really good to integrate with the system. So, your product might be, deemed to satisfy with non-combustibility or something like that, but the insulation behind it might perform very poorly with it. So there can always be that. So yeah, I always think that if you are going to do it, it's good to actually have or ask for any of that extra testing. I will point out it doesn't have to be Australian testing. If you've got BS 8414, NFPA 285, that kind of thing, something's better than nothing.
Okay. A little bit of confusion. Is bonded laminate, the reference to bonded laminate, the same as an aluminium composite panel?
So an aluminium composite panel is a bonded laminate.
Okay.
So bonded laminates is the bonded laminate clause is the part of the NCC. So C1.9E number 7 or C2D10 and all the way down the bottom. That's the pathway for compliance. Other products use that. So like insulation, some cavity barriers. So it's not specifically for aluminium composite panels, but an aluminium composite panel is a bonded laminate.
Okay. I'm doing a reclad. Can ALPOLIC be color matched to what's on the building? If there's a reclad, what do I do? Can we get a match? Similar?
So yeah, we can. One thing with reclads I always like to point out is that if you can get whatever the original color was that was on the building, if it wasn't ALPOLIC FR on that building, then it was more than likely a PVDF coated aluminium panel. Which will have faded over time. So I try and color match what was put on there originally, not what was on there now. But we can certainly do either or. Mitsubishi are excellent at color matching.
Excellent. I'll stay on color. What can we get? Solid colors, timber, metal. What's the range? What can I do?
So we can do, so we can imitate metal. So like copper, zinc, those kind of colors, like very close to stainless steel. We can do metallics. We can do solid colors. We can do patterned wood grain colors. We can do prismatic colors as well, sparkling. So we do have a very wide range of colors that we can actually offer on top of color matching.
Beautiful. Question: you mentioned FR and NC.
Mm-hmm.
What is the difference between the two, and do I need to remove FR to replace it with NC, or where do we stand there?
So ALPOLIC FR was introduced in 2000. So ALPOLIC FR is 70% non-combustible or inert material, and then the other 30% is polyethylene or a polymer content. So that's the main difference. The NC doesn't have any polyethylene content in it. So the core, because someone else asked this question, of the NC is aluminium trihydrate and calcium carbonate. So to answer the second part of that, it depends entirely on the council and what's behind it and the fixing system itself. So our ALPOLIC FR, if it was installed onto top hats and the substrate behind it's good, like it doesn't have polyester insulation, or wasn't double-sided tape fixed, etc., it's fine to stay on. Generally speaking, it can depend on the council, though. I will highlight that. Clint and I have tried desperately to keep it on. We've kept it on, a 20-story building in Milson's Point, and then we've not managed to keep it on a 3-story apartment building, in the Southern Shire. So it's just kind of, it depends on who it is in the council, and I guess the engineer as well. If you ever do want any advice with that, please come to us directly. We're more than happy to help out with that.
Okay. Now, advice. So my practice has a no ACP policy. Our insurers won't cover it. The legal team have gotten involved. Do you see this changing? Are you directly speaking to insurers? What's the best way to go about it?
So the second part first, yes, we are speaking with insurers, which is why it's changing. I referenced before in the presentation EN 13501-1, and we have an A1 classification. So a lot of the insurance underwriting has come from overseas, specifically like the UK. So that's what they recognize. We went to insurers and we were showing them strain standards, part 1, part 3, 5113, large scale testing, that kind of thing. And they were like, that's really cool, but we just don't care. And then, through some digging from their risk team, they actually found out that it was an A1, and we started promoting that more and more because that's what they recognize. So now, there is as always, what happens with insurance, everyone will say no, and then someone says yes. Insurance companies want to make money. If someone's insuring something, then, they all want to make some money off it. So we're having a lot more success with it now. If you do have a policy which restricts you, please get in contact. We can always put you in touch with an insurance company who will actually provide cover. But I would say more than likely that when you're coming time to renewal now, it will probably change from no aluminium composite panels to this. As long as the products are non-combustible and they comply with the building code, then it's fine.
Okay, so navigating facades, confusing, and particularly you showed us some great tests. Do you know why solid aluminium is approved, but like your tests perform better than a solid? Do you any thoughts, or you just don't know?
I can give you thoughts.
Yes.
Which would be thoughts only in my opinion, but
yes.
3mm aluminium was used before aluminium composite panels, so it was kind of going back to something that you knew worked. So there's that first bit. I think there's very much like a psychological aspect of it where, you're like, it's metal, it's not going to catch fire or anything like that, it's going to be safe. If you're a history buff or anything like that, kind of like me, they stopped making aluminium warships after the Falkland Islands because, they fired a missile into that and the whole thing kind of erupted, like instead of making it out of steel. Solid aluminium, just as a product, it's, it melts at 660 degrees. That's it. It's just a homogeneous product. It doesn't have any fire retardant properties or anything like that. It will just start to melt and fall off. I think its acceptance was just based off the fact that aluminium is easy to work with and use. It's easy to work with in steel. It's easy for them to roller coat. So it was kind of the best of a bad situation. Unfortunately, now everyone's coming out and going, well, we put up these panels, they don't look the same, and they're oil canning. So it's all the lessons that they forgot about 30 years ago.
So it's absolutely reminder. It's asking those right questions. Hopefully it's not all of the above, but it is really about asking all of those questions. So please keep them coming through, guys. Pricing, we'll talk about it a little bit. Is NC the same price as similar products, solid, the corrugated core that sort of comes in, or does your warranty just blow them out of the water?
Well, yeah. So the upfront price, yeah, it's very similar to 3mm aluminium. When it comes back down to the warranty, and when I say it's very similar to 3mm aluminium, like on the wall, supplied, installed, it's been fabricated, all that kind of thing, they're both on par. We're probably we could be about $10 a square meter cheaper after all of that. Using less stiffeners, the time it takes to actually fabricate and manufacture the product. The corrugated core, I refuse to really kind of acknowledge or go, it's a cheap product. Yeah, you get what you pay for with that. There's nothing really, there's no saving grace to that product apart from the installer who finds it very light, and they don't mind that. In terms though of the overall cost and the life expectancy for that product, again, you don't have to maintain or wash down the ALPOLIC NC in order to maintain that warranty. With those other products you mentioned, you do have to wash them down. So,
Okay.
You think about like a 2,000 square meter job, $15 a square meter, 2 times a year, whatever cost saving that you thought you were initially going to make because you specified a product that was, more cost effective, you've already lost it in that first year, and there's 19 years to go on that warranty.
Yeah, another thing to take into consideration too is it's definitely to check the frequency that it needs to be cleaned down. Some of them, if the project's located on the coast, it'll often be every 3 months. So it can be every 3 months, 6 months, sometimes it's every 12 months. But basically, yeah, if you don't wash down the facade and have a record of washing it down, the warranty's broken. There isn't any warranty. So that's where ALPOLIC is really sort of stands on its own as a product.
Absolutely. Now, there's actually a few questions coming through on fixing methods. Can you detail that a little bit more? There's quite a few on fixing methods. How do you do it? What's the recommendation? You did make a couple of recommendations as part of the discussion. Talk us through that.
Yeah, so the only fixing method that we recommend is cassette fixing. So cassette fixing is when you route the back of the panel and you fold it up into like a pan cassette system. So that's got aluminium Z angles. You fix that through the side of the aluminium composite panel, and then those aluminium Z angles then get fixed onto a steel substrate. So that's the primary fixing method. If you want to, you can face fix it. From an aesthetic point of view, I really think that's a bad idea, mainly because of the fact that you're paying, X amount of dollars for a product, it's a premium product. You obviously want it to look the best it can. So the cassette system is, it's a sealed, it's like a concealed fix system. It's a lot better. Those are the only two methods though. At no point at all should you be doing anything other than those two. If it's double-sided tape or adhesive or anything like that, big no-no. Shouldn't be doing that ever, especially not with the ALPOLIC.
A couple of questions coming through around testing. There was a couple of tests coming through in terms of different testing or cyclone testing required just in cyclone zones, or do you recommend other testing elsewhere?
Cyclone. So if you are building anything in a cyclone rated area, which is mainly like that top portion of Australia, there's a certain line that runs through the top part. Not quite like the Brisbane line, but something similar, where you do have to have that. Cyclone testing though is really good as as an augment to FP 1.4 and your weatherproofing. So a great example is we're doing a reclad in Sydney along Darling Harbour, and the facade engineer came back to me and said, "Can you please send me a cyclone test? There's one corner at the top of this roof which has a 5 kPa wind rating, and we need your cyclone test for that part." Now, 5 kPa is a cyclone; it's extremely high. So it did certainly help with that. It just, when we're talking about doing more of this testing, it just adds more to the robustness of the product itself, so that you can turn around and go like, we're giving a lot more options and a lot more flexibility in the terms of the design. So that if you do have any of those areas, you can still use the ALPOLIC all over that building, instead of having to go to something else potentially.
Yeah, and it gives the owner confidence that, you know, that the product will perform in the long term, and especially now since there's a lot more extreme weather that we're experiencing as well. So that's that's the main point.
And I suppose speaking to extreme weather, obviously Australian UV, FEVE, which is the recommendation, the Lumiflong over the PFDF. Is it more expensive, or where do you sort of sit or compare with that, or is it again longevity? You get what you pay for.
I mean, well, with a FEVE and and 3 mil aluminium, 3 mil aluminium is in PVDF, but it's the same price on the wall. That for us, there's no price difference in between. When you're in the manufacturing process, it's a built-in. PVDF is absolutely cheaper for them to apply. You still end up paying something very close to what you're paying for the NC, and the NC, you're getting a premium product with a premium paint finish on it. So, yeah, like in terms of cost, the difference there isn't anything upfront. But again, there is that ongoing maintenance cost that you do have to have for that PVDF.
Going back quickly to warranty, just had one coming through. So with the maintenance, and Anna, you mentioned sort of a 3 month, and then 6 months, and then 12 months. Everybody's got sort of different recommendations. How strict do we need to be? As soon as you miss one, it's gone, like the warranty's gone?
We don't have those stipulations in our warranty, so I can't really speak on what another supplier can and will do for you. Historically, I'd say no. It would be gone. I mean, if you're really thinking about it, yeah, it's up to them whether or not they're going to turn around and go, yeah, you've been doing it, but you missed one. But it depends on how much they're going to be up for. If it's one panel that's failed, they might give it to you. If it's a whole building that's failed and you missed one cleaning, I'd say, yeah, you're not going to get any money out of them.
Yeah, I think that the main point is it's just important sort of upfront when specifying materials and things, just to, there's a specification, but then there's also the installation, but it's actually checking what the requirements are to maintain that warranty. So that is the key. But obviously, if the warranty it'll have a cleaning and maintenance course for anything with a PVDF coating. So in theory, if you haven't met those conditions, then in theory the warranty is not valid. So again, that's other manufacturers. So you'll just need to ask the other suppliers.
So again, it's questions, following up and making sure that you have that information. And the network architectural team are really here to answer all those questions. Guys, if I can ask you to touch on what's the takeaway? What do you want everybody to take away from this? And remember, it's questions. It's making sure that you've got your warranties, your details, your testing. Anything else that you want to make sure that people are asking or doing as part of specifying an ACP as part of a reclad or a new build?
Yeah. Someone's touched on it in the questions with chain of responsibility legislation. Like the onus now has never been tighter on anyone in that chain of responsibility, from builders, suppliers, architects, installers, any of the consultants, anything like that. So like that's something to definitely consider. So when you are turning around, we're telling you to ask these questions, obviously from the point of view that we kind of want a fair and equal playing field, from a supplier point of view, but now it is actually coming back down to a legal point of view, that you actually do have a responsibility to turn around and actually now ask these questions from these suppliers, to turn around and say, okay, so the tests that you're giving me, are they good? Is there any other tests? Has this product ever not performed as, advertised or anything like that? By doing this, you're covering yourself, but you're also covering the end user who's going to be in this as well. So we're going, through Project Remediate or Cladding Safety Victoria or all these reclad programs across Australia. Like the end user here are people who live in these buildings who shouldn't be paying for these reclads, but they are. and it's about them, you know. So that's the main point of view that we want to. You're asking these questions so that you're providing the best product you possibly can. And I think sometimes in the building industry we kind of forget that, but it is, you know, all about you know, that quality that comes from what we provide and from what you provide as consultants.
Yeah, and I think just looking at it holistically and from a longer term perspective, which obviously feeds into sustainability, it feeds into the whole life cycle cost. So rather than, I think as an industry, and, you know, one's looking just at, oh, what can I get for the cheapest rate, you know, to start with, and you're sort of not looking at the longer term and how that actually sort of plays into it. And often when you're choosing a product that is a higher quality product, it may be a little bit more expensive up front, but it may not. Like it may be marginal, but from a longer term perspective, you're actually selecting something that's a lot more sustainable and also a lower cost option. So it's a win-win scenario, and especially for be it, you know, strata or be it the owner of the building, that I think we owe them, you know, to be guiding them in that way as well. So yeah, and that feeds into the chain of responsibility as well that's coming into play.
Brooke, one of the questions we were asked that I actually made a bit of a mess of and hit the wrong button was, can you clarify the costs of a large-scale test? And
Yes.
Is this test in places deemed to satisfy? So the cost of a large-scale test as an AS5113 is in the vicinity of $75,000. So we've now, across our range of products, done around about 9 or 10 of these tests, just to prove that the safety of the material that we're working with. And this is one of the reasons that the other, I'm not going to call them manufacturers because they're not manufacturers, they're suppliers, don't do the test because they know the catastrophic results of how solid aluminium performs in that test, and they're not going to waste $75,000 on it. The second part of the question is this test in place of deemed to satisfy? No, it's not in place of deemed to satisfy. You can still use deemed to satisfy products that are deemed to satisfy, such as ALPOLIC, and Llewellyn ran through the requirements to be deemed to satisfy. The 5113 test is really there for, as a compliance point of view, for combustible materials to show that they don't spread flame, that don't pass the deemed to satisfy requirements. Now, I don't think we've got the testing 100% right yet. I think you know, there's other methods and other things that we can probably do, and look at global testing and global results to come up with a better, clearer result for people. But you know, then the main part of the question is, are they expensive? They're very expensive, and yeah. So that's, hopefully that answers the question to Andrew.
Who pays and who pays?
We do.
Very expensive.
We do.
You pay. So
Yeah,
you've gone out and tested your panels to have that proof.
Absolutely. We get the same suppliers knock on our door all the time saying, you know, can you sell our solid aluminium, or can you sell our corrugated core material? We'll cut the film off and we'll put raw film on. And we say to them, if you can show us that your product passes a large scale water test or provides evidence of safety in a large scale water test, we would consider it. But none of them will do it because all of them fail and fail dismally. So we've copped up every single time. We've got $75,000 plus, at least 9 or 10 times now to prove to the industry, and a lot of it was to prove to Project Remediate and all that sort of stuff that our material is actually safer than the product that is actually being specified.
Well, facts, tests, they speak for themselves. A big thank you to the team from Network Architectural. Thank you for shedding the light on the intricacies of facade design, and it's really clear that every detail, every question matters as we build for the future. As we move forward, another exciting session is lined up for you. Next up at 11:30, we have Real Flame. Funnily enough, we're still talking about fire, but in a different, more contained way, I suppose. Electric fireplaces as a simpler and green alternative. As we look for sustainable and efficient alternatives in design, this session promises to be both enlightening and warming. So stay tuned and get ready for another dose of knowledge and inspiration. Enjoy your morning.
Thank you, everyone.
Thanks, Llewellyn. Thanks, Anna. Thank you, Clint. We'll see you soon, guys.
Bye.